So, welcome back to Cloud First. In today's session, we're going to talk about applying DevOps principles with machine learning. I am Mohammed Osman. I work for a company called BWC. It's another small company. So, I work within the data and analytics team. I work as an Azure and AI developer. I run a blog. I call it Smarter Code, and it has a message making your code smart and your career smarter. So if you want tips and tricks around how you make your career smarter, like how you negotiate your job offer and so on, and other stuff to make your code smarter, please check it out. I create some courses for Prover site. Mainly I am focused on Azure and machine learning, and I am a gamer. Who plays PUBG? Is it only me? That's embarrassing. Okay, so let's jump to the agenda and see what you're gonna learn today. So we're gonna start with a crash course in machine learning. Who is familiar with machine learning? Okay, around 50%. That's great. Then we're gonna look at a practical experiment in machine learning that we're gonna see how we will apply machine learning steps in that experiment step by step. And then we're gonna discuss a new concept. Has anyone heard about ML Ops? Yeah, that's a new concept. It's a cousin of DevOps. And we're gonna see how we can apply it with machine learning. And of course, we're gonna have something that's hands-on. Okay? Any questions? And then of course, there is a Q&A session at the end. So, machine learning. So, this is some blah, blah, blah from Wikipedia. You don't really need to read it. But the whole idea about machine learning, as compared to the regular programming, we hardcode specific rules, right? So let's say, for example, I want to calculate a salary. I know, okay, I have a base salary, I have a tax deductions, and so on. So I have a very specific set rules. With machine learning, it's a different story. I don't have a clear rules in order to answer a specific question, but rather I have an all data. I use that data to train what's so-called machine learning algorithm. From that algorithm, I can apply some predictions to get nearly close answers. Okay, that's the whole idea of machine learning. There are so many applications of machine learning. One common application is sales forecasting. So if you have a data from your CRM or ERP system for the sales for the last year, you can predict the sales for the upcoming quarter, hopefully, as long as your data is accurate enough. Customer segmentation. So, for example, if you are a telecom operator like Telia, and you have a big customer base, millions of customers, and you want to send a targeted offering for each customer, then you can use a machine learning algorithm to segment those customers into different segments and then send them relevant promotions and offers based on how they consume, when they consume, their age group, and so on. Another common application is email spam detection, and that's used quite commonly by Google and Microsoft. So they analyze the spam messages, see what are the common keywords. For example, if you get an email, I think all of us got that email. I am a president of a country X, I got thrown out, and then I have $10 million, please send me your bank account details. Has anyone received that email?
Yeah.
Yeah, I always get that email. And the funny thing, the president of our country was thrown out, and I know that he is in the prison, and I got an email from him. I told him, come on, you don't send that to me. So, if you go to practical things with machine learning pipeline, it all starts with your problem definition, how you define your problem, what the questions you want to answer. And then you go to we're going to look into more details, but on a high level. Then we're going to process the data that we have to answer that problem. Then we're going to do some work in order to train the machine learning algorithm. And finally, we're going to deploy that model. Okay, problem definition. So whenever you are given a task to implement a machine learning project, you need to find out what the question I want to answer. That's the most important thing. Because from this one, you're going to drive all the remaining steps. So maybe the question you have, I want to segment those customers into different categories. From this question, you're going to go to the next one. You will need to source the data, right? So you need to bring relevant data from there. You're going to need to integrate with the ERP system, maybe. Maybe you need to integrate with the CRM system. After that, you need to prepare the data. So most likely the data you will get from different systems are not really so nice, and then you need to make this data nice enough, make it clean enough, make it in a consistent format, and apply some machine learning related tricks that we don't really care about right now, so that your machine learning algorithm can accept it. And then you need to segregate the data, and the reason is that in machine learning, when you have a data, you need to separate it as a training data and test data. The training data, you will use it in order to train and teach your machine learning algorithm, and then you're going to test that model, right? You want to make sure that it's doing correctly, and then you will test it with the remaining data. That's why we need to segregate the data. And then you will train the model by the training data. You're going to evaluate the model using the evaluation data, using the testing data. Sorry. Then you're going to deploy that model, right? At this stage, if you are happy with the results of the model evaluation, you can take that model, deploy it to production, and make it accessible by the users. Finally, you will keep monitoring the model in production to make sure that it's working fine. It's not facing what's so-called model drift. And model drift means that if your machine learning model stays in production for a long time, it can actually become outdated, right? So if you are relying on data based on customer purchase behavior, maybe customer purchase behavior has changed during the last 3 months, during the last 6 months, if there is an economic shock. So you need to make sure that you are always training and updating your model. Okay, that's it on the machine learning pipeline. Any questions? Crystal clear? Perfect. Now we're going to look at an experiment that implements this machine learning pipeline, and we will use it as a base for the remaining of the presentation. The experiment exists in this URL. You don't need to follow over. We're going to go over it step by step. So let me launch this URL. Need to make the presentation. So, okay. Are you familiar with Google Collaboratory? Okay, Google Collaboratory, yeah. It's a tool from Google that enables you to run what's so-called Python notebooks. So essentially, when we are implementing machine learning models, we are using Python as a programming language, and it's just a way for us to run Python on cloud. So you don't need to install any tools or anything. You can find it just if you Google Collaboratory, you will find it. Over here, I have implemented a machine learning experiment. We will go through it step by step. And I'm going to show you the steps of the pipeline on each corresponding line of code, okay? So problem definition. Oops. Yeah. Problem definition. So the problem we have here, we have a data related to car, or so many cars, more accurately, including acceleration, age, mileage per gallon, and so many other attributes that we're going to look about. Based on this data, we want to predict what's the mileage per gallon of a specific car, okay? So that's our problem definition. And that corresponds to the first step in the machine learning pipeline. The next step, we're going to source the data, right? So we need to find the relevant data in order to do that training. And to do that, I'm going to import a machine learning library or a package when we are using Python. It's called pandas. Pandas essentially make it easy for me to manipulate and deal with data. I'm going to run this cell. Sorry, I need to make sure. Okay, so the cell has executed successfully. The next step, I'm going to import the related data or data source. For that one, it exists in this GitHub URL, okay? And then I'm going to show that data. So I'm going to run this cell as well. It will take a few seconds. And over here, as you see, I have the mileage per gallon, the number of cylinders, displacement, and so on. This is the data I have for the car, right? Maybe I have a data from so many data sources. But right now, I'm just making it this very simple data source for sake of presentation. Next, we will need to prepare the data. As I mentioned previously, maybe the data you have is not good enough, it's not clean, maybe you have some missing data and so on. You know, data in real life is not that good. So we need to make it good enough. I will look at the shape of our data. It tells us that we have 398 rows. We have 9 columns. We can look at the data types. You don't really need to care about this Python syntax. I just want to show you the data preparation steps. And then I see that, okay, I noticed that the horsepower is actually of type object, and that's uncommon. It should be a number, right? So if we look here, it's 130. If it's a type, if you have in Python or in Pandas, you find that something is in a type object, that means you have a problem in your data. Maybe there is a string or something like that. So I run another function to force a conversion, and I will give it a parameter code. When there is an error, cures that error, which means that it will convert it to a Python construct called not a number. Now it did the convergence. And now I will run another Python function that will check all the null or none or not a number values and inform me about them. And here it checked all my column. It told me that for the horsepower, actually there are 6 values that doesn't have a number. Okay? I need to fix that. I can fix it by another function called fill_NA, and I decide to fill it with the mean value. So all these missing values, I will fill them with the mean. I will do another check, and as you can see, all of them are now 0. And now I decide that, okay, you know what? The car name is not really useful for me, not useful for my machine learning model. I'm going to drop that. So I drop it. I give the data another look, and this is how the data right now looks like. Okay? So then I know that, okay, I have what's so-called features in the data, and the features is whatever you use to train the data. And then you have the label. The label is what you want to predict. In this case, it's the mileage per gallon. So I will separate them to X for the features, Y to the labels. Is that clear? Perfect. And that ends our data preparation step. So what we have done, we had a really ugly data, we removed some columns, we filled missing values, and so on. Now our data is ready. The next step, we need to segregate the data. Again, I will use a Python library. It's called scikit-learn. It's used for machine learning purposes. And that library has a function called train test split. I can use that function in order to separate my data into 2 parts, training data and testing data. And I tell it that I want the testing data size to be 20%, and that actually makes sense, right? Because you want to train on a huge amount of data and test on a smaller amount. So what will happen here, it's going to split it to 80% training, 20% testing. You can adjust these values if you want. Next, I will do the model training step. So after I have prepared the training data and testing data, I'm going to import what's so-called a machine learning algorithm. Okay? There are so many machine learning algorithms based on the problem you want to solve, right? There are problems in machine learning called regression problems, where you predict continuous numerical value. There are classification problems where you classify things, and there are so many types. We don't focus on that, but the whole idea, this is one type of problems that can be solved. Why I have chosen linear regression algorithm? Any question? Any ideas?
It's simple.
Exactly. And it's the type of the data we want to predict, right? The mileage per gallon, it's a continuous value. So mileage per gallon is not a classification. It's a numerical value. So that's why we need to predict it this way. So the design decision on how you choose your algorithm highly depends on the problem or definition you have. Perfect. It's now executed the model. Now I'm going to evaluate the model. And again, how you evaluate your model depends on your machine learning algorithm. Classification algorithms has different way to evaluate them. Regression algorithms has different ways. We won't go into that, but you just need to know that on a high level. Over here, when we are talking about regression algorithms, there are two metrics we care about mainly. Something called the R squared and something called the mean squared error. The whole idea is that the R squared value, the closer to 1, the better. The mean square error, the less the better. So what I do here, I run some code to calculate those values. You don't really need to care about how that code works and so on, because this is implementation detail. So I'm going to run it, and here you see the result. This is my R squared value, and this is my mean squared error. Now I have my model, I can test it. So I can pass to it an array of inputs. That's why you see array of array over here. And I can print the outcome. So that's the outcome of prediction. Okay, now I have built the machine learning model, trained it. How I can use it? That's what takes us to the model deployment. To do that, I did a simple implementation. I used what's so-called Flask ngRook. Are you familiar with Flask in Python? So Flask is a way to implement an API similar to ASP.NET Web API. So it enables you to implement APIs in Python. When you use it in conjunction with ngRook, ngRook is just a hosted server. So essentially, this will help me to implement an API and host it directly so that I can test it with my Postman. I will need to install that package. This is how you install packages in Python, similar to NuGet. And over here, there is a really long code, but the whole idea of that code is it builds an API endpoint that takes a post request. That endpoint has the address /predict. And over there, it's going to parse some parameters from the query string. In the query string, I am going to pass in the input features. The input features, it's those ones. Okay? So when an external consumer wants to use this API, they're going to send me those parameters. And that API will consume those parameters from the query string, and it will serve the response pipe. We can test that as well. Yeah, I will need to run the cell. In the meantime, I can prepare Postman. So here, it gave me some output. Over here, it says that it's serving this API on this URL. So it's going to spin up this on the fly, and it will provide you with a URL. I can use this URL. It's exposed to the public internet. So I can use it from my computer. I will copy this URL. Go to Postman, dismiss. I will need to update this one because every time it's going to generate a unique URL. And this is the request I have. It's in a query string. Send. And this is the result. You see? So we have built an API. We have taken the data source. We have cleaned the data. Then we have trained. We have segregated, then we have trained, created the machine learning model, hosted it. Isn't that great?
Yeah,
perfect.
Stop selling.
Yeah. I wish if I had something to sell with this. Okay. Any questions, by the way, on this? Perfect. Come up. PowerPoint is stuck. I'll need to close it and open. Okay, finally. But frankly speaking, this approach has many problems. Can you foresee any problem with this approach? The first thing is that there is a lack of infrastructure, right? So if you want to take this and use it for a real life machine learning project, this doesn't work, right? You can't serve a model this way just by having it in a Google Collaboratory and providing a URL. It has a timeout. If you just leave it, I think, 15 or 20 minutes, it's going to kill all your resources. So it doesn't work. The second problem is that there is a lack of source control. So what if we are a group of data scientists working on this together? We are changing the models. We are trying different machine learning algorithms. There is no traceability. What if I have different versions of the machine learning model? I want to try different versions against each other. That's not possible as well. What if my data changes over time, right? Maybe new cars will come up. They will have a different attributes. Technology will change. Things will get better. So this data will become obsolete. I will need to train continuously in order for this machine learning model to stay relevant. So the question is, what's the solution? And that's what takes us to the next topic, ML ops. Okay? Any questions regarding the machine learning experiment, by the way?
Do you know if there is any equivalent of that Google collaboration thing in Azure? Some notebook thing for?
Yes, there is something called Azure Notebooks.
Okay. Yeah.
I think it's discontinued, by the way, but I have seen them somewhere.
Okay.
Any ideas if you heard about Azure Notebooks? Are they still alive?
I don't know.
Okay.
I've not been there for a while. It would surprise me if they were discontinued.
Yeah, I think I read that somewhere, but in the machine learning resource we're going to look at, there is a way to do that as well. But the good thing with Google Collaboratory, it's public, so you don't even need to pay for it. As long as you have a Google account, you can use it. So ML ops. So the whole idea of ML ops, again, this is like a long definition, is that it will help you to take your machine learning model that you have as an experiment, and that's quite common. Like data scientists, they are not super used on productionalizing the machine learning model, like taking it to production. It will help you to take your machine learning model from an experiment to a real life machine learning that you can use, productionalized machine learning model. So how it helps you? Number one, it helps you with creating infrastructure as a code. So all the required resources in order to train your experiment, in order to serve the experiment, can be created using MLOps. And then you can implement source control with that. So you will have traceability, you will be able to commit your code, review the code with other data scientists, and so on. Of course, you will be able to version your models. So if you want to go back to an older machine learning model which you found that has a better predictions, you can use that. You can compare models to each other. You can A/B test models. And of course, you can retrain models. And there are so many other benefits, including you can monitor models in production, you can see issues and problems, and so on. Okay? So in short, MLOps brings to machine learning model what DevOps brings to software development, right? So in software development, we have our software isolated. It's not connected to like the operations part, but when you start implementing DevOps, then you get all those benefits. You connect user stories to features, and then you can connect it to issues in production and so on. This is the same idea. Any question before we dive into the hands-on part? Yeah.
Okay, so now in this case you created the whole model from scratch
Yes.
with your own data. But are they like, I mean, if you don't have so much data, are they like public data or public models or something like that that you can reuse or build up upon yourself?
Yeah, that's a very good question, and I would separate that into two different questions. So the first question: are there like a public data sets that you can use? Yeah, there are. There are many data sets. There is a data set called, I think it's MIDST. Yeah, so there are for so many different things. It's not only data sets. There are so many images and so on. If you want to implement what's so-called deep learning. And another part, something called transfer learning. That's also like a field within machine learning where you can reuse existing algorithms and adapt them somehow to your machine learning problem. Yeah. But most likely, if you have your unique business problem that's unique to your domain, then you will need your own data, of course. Any other questions? So, how many of you are familiar with Azure Machine Learning? Okay, then we need to have a quick walkthrough on it. Azure Machine Learning. So I'm gonna keep that really short. So Azure Machine Learning, it's Azure resource like any other resource, but it's purely focused on helping you to implement machine learning experiments. There are so many other resources connected to it, like storage, virtual machines for processing, and so on. But the main orchestration and processing is done on that resource. When you start working with Azure Machine Learning Studio, it's a part of Azure Machine Learning resource, and actually it's the main one. There are a few things. The first one, just let me. Okay, just 1 second. I need to start another software. Okay, so there are so many different parts with Azure Machine Learning model. We're gonna start with the first part, and that's related to the data. So the first thing you can do, actually I like this tool and decided to use it. It's called Zoom It. It helps you to create. Is it? Can you see, by the way, this part?
That's better.
Huh? That's better?
A bit more to-
Okay.
Thanks.
Yeah. Okay. So, firstly, you can connect your data sets in Azure Machine Learning Studio, so that you can use it later on to train the model. After you connect the data, you can author an experiment. And authoring simply means just creating all the stuff we did in Google Collaboratory. So you can train your machine learning model, use different experiments and so on, and you can do it different ways. You can do it either in notebooks, similar to what I have done, but in Azure notebooks. You can do it with something called automated ML, and this is just a fancy way from Microsoft. They will figure out which machine learning model could work for your data. You can use it even with a drag and drop designer. So if you have a data scientist who is not familiar with Python programming, they can use that. The whole idea in this authoring section, you're going to create your machine learning experiment and so on. After you have authored your machine learning model, you will get an experiment. Okay, so over here. And simply every execution or not execution, but every machine learning project is an experiment. In that experiment, you can have so many different runs as you try and execute different data sets, try different algorithms. And the result of that execution is what's so called machine learning models. Okay, and that's what you will get after training the data. And then you will get what's so called also endpoints. So simply after the model gets trained, prepared, then you will have an endpoint. Endpoint is just a URL that you can use in order to use your machine learning model in real life. Okay, so this is like a production grade way of doing the machine learning stuff. You can deal with machine learning studio in so many different ways, like any other Azure resource. There are SDKs. You can use the command line and so on. Any questions regarding this? It's a very big tool. I am just taking it on a very high level, like I'm taking only the parts we need for this presentation. Cool. Then we can go and see what we're gonna do. So moving forward, what we will do, the prototype or the experiment we had in Google Collaboratory, we're gonna refactor it to become a MLOps grade machine learning experiment. And to do that, we will need to use Azure ML so that we can store our experiment, run all our stuff and so on. And we will need to use Azure DevOps. Why Azure DevOps? Because it helps us with the DevOps part, right? We can store our code, we can run pipelines, we can have traceability and so on. So how we can do that refactoring? Actually, there are two ways you can do that. The first option, you can reinvent the wheel. And simply it means that you do everything you need from scratch. So you will create all the required ML infrastructure yourself using either ARM templates, Terraform, or whatsoever. You provision the required machine learning processing resources, because for those experiments to run and execute, you need resources. You need to implement that. And then you need to write the code to create the experiments, to load the data, perform all that stuff. And then you need also a code in order to deploy things from Azure DevOps, implement all that, okay? And it's a lot of work, actually. It's too much to do this. The other option is that you can reuse the wheel. So you can reuse existing solution. And that's a project called MLOps Python. Did anyone hear about that project? Okay, perfect. So it's a container for the boilerplate code, which means that all that stuff we spoke about that you need to do yourself, create machine learning experiments, create processing resources, and so on, there is a project already out there that does that for you. So you don't need to care about, the boilerplate code to create all that stuff. You just put your experiment. It will create all the infrastructure and stuff surrounding that. It contains all the required DevOps pipelines, whether they are to train the model, to release the model, or even to create the infrastructure. This is for train. Hi. Yeah, so cute. Yeah, so it contains training models, pipelines, model deployment pipelines. It contains so many different configurations that you can configure on the fly for your experiment. And finally, it's an open source project, okay? We can have a look at that project in GitHub. So that is the MLOps Python project, okay? And it's actually it's a quite complex project, but we don't need to focus on everything over there. There are certain things that we need to care about. The first one is the pipelines. Is it clear, by the way, or do I need to zoom in? Perfect. In the pipeline section, there are so many files, but there are only 3 of them that we care about. The first one is diabetes regression continuous integration. And by the way, diabetes, that's the name of the experiment. That's why they called it diabetes experiment. That's over there. In our case, we can call it automobile MG, but we're gonna have a look at that. So this file contains build definitions for continuous integration. Continuous integration here means model training. So over here, they have a very detailed pipeline that will create all the stuff you need in order to train your machine learning model. Okay? You don't really need to care about this right now. The second one is continuous deployment. And this all the stuff that you need to deploy your model. Okay? And the last one is something called the variables template. And over here you can have different configurations for your experiment. Let's have a look at a few of them. For example, here you can configure your experiment name. And that's the experiment name that will appear in Azure ML. You can configure the name of the data source you can use, and so many other configurations. The second section we will need to look at is Bootstrap. So Bootstrap is simply, as you have seen, this project is named as diabetes. When you have your own project, in this case automobile prediction, you can use this Bootstrap. What it will do, it will just rename everything from diabetes to Bootstrap, so you'll have a nicer project names. We're gonna have a look at that soon. Next, we have environment setup. And here, simply, this is what creates the infrastructure. There are actually two. Oops. There are two types of pipelines over here. So there is an ARM template, and there is a Terraform. This will just provision the Azure ML infrastructure we have seen in Azure. It will create all that infrastructure you need. And the last part, you will find it under your experiment name. And that's diabetes regression. Over here, you will have something called scoring. And this is where you're going to put the logic, where you perform the prediction results to the client. And only here we care about one file called score. So here we just gonna put our code that performs the prediction. Remember, everything around is boilerplate, is prepared for you. So you're just gonna modify small parts based on your experiment. The rest is ready for you. And another one you need to do is to train your model. Again, you will need to replace some code over there with your experiment code. After that, you will be ready to run. Okay? So, oops. So the whole idea of MLOps Python project is to remove all that boilerplate stuff, creating infrastructure, code to create experiments and so on. Leave it for Microsoft or the open source community, and you just bring in your experiment code. Okay? Does that sound clear? Any questions on this? Perfect. We can continue. So let's see how we can implement that on hands-on. So the first step we need to do is we need to customize our experiment. So it all starts that we will bootstrap our project, right? And the bootstrapping, what will do? The bootstrapping step will do? It will simply rename project from diabetes to automobile or whatever you name it. And then we will need to update some configurations in this file called automobile variable template. We can enable application insights if we want to have results for that prediction being posted to application insights or errors being posted to application insights. We will need to customize the training code. We will need also to customize the test train code, and this is where we split the testing and training data. And we will need to update the scoring code. Okay? And in order to save the time, I have that already ready-made, so I'm going to show you in Visual Studio Code. So the first thing you will notice is that over here, the experiment here, it used to be diabetes, right, when it was in GitHub. But over here, it's automobile. Why? Because I have bootstrapped it, right? So the bootstrapping helped me to rename everything. And then under the pipeline section, if I go to, need to expand, automobile variables template, you will see that I have updated few things as well. So have updated the name of my experiment that will appear in Azure ML. The name of my dataset. This is automatically has been renamed by the bootstrapping. Over here, you can also configure so many different parameters related to the training clusters you're gonna use and so on. Azure ML related stuff, you don't really need to care about it. But the whole idea is that you can configure that, okay? Next, I'm gonna go under the experiment, and then I will go to the training, and then I will go to train, and you will see here that I have updated my training functions. For example, I have introduced this function called split data. Actually, I didn't introduce it, it's already there. So it's like a skeleton existing over there from you, and the project expects you to split the data and return it in this function. This acts as an interface that will be used by the rest of the project. It tells you, okay, just bring your experiment code, split your data and return that to me. If you do that for me, I know how to do the rest, okay? That's used throughout the rest of the project. The same used for the get model metrics. Those metrics we got in Google Collaboratory, if you remember them. Do you remember the metrics? We can return them from here. That's also needed by the rest of the project, so that the project can see the model metrics, and later on it will use it, for example, to tell if you introduced a new machine learning model, does it have a better metrics or not? If it has a better metrics, then it will replace the existing model and serve it. Otherwise, it will keep the old one. And that's it pretty much, actually. There are so many other configurations like Python environment and so on, but that's not important for now. So the whole idea about this is that we took this project, took our experiment, took the relevant parts, we inserted them into the project, okay? And then we will deploy the related part on that project, and we will have a ready-made or production-grade machine learning project, okay? So we can continue. So right now we have customized the experiment, and then we will push it to the repo. It's already pushed in Azure DevOps. We're gonna have a look at that soon. Any questions, by the way? Okay, perfect. The next step is that we're gonna create the machine learning infrastructure, and this is a very easy step. So we will need to go to Azure DevOps. We will need to create a couple of service principles. Are you familiar what a service principle is in Azure? Yep, perfect. The idea is that Azure DevOps needs that service principle in order to be able to provision resources in Azure. That's the whole idea. And then we will create a variable group, and it's simply just a bunch of variables in Azure DevOps that can be used by the pipelines. Then we will create the ML infrastructure. We will create the infrastructure pipeline. We will run the pipeline. We're gonna look at the resources in Azure. So let's go to Azure DevOps. So over here, I have this project. And if I go to the repos over here, files, so I have everything pushed over here, okay? The first thing we can have a look at, if I go to the project settings, service connections. So you see that there are two service connections. One for Azure that will create resources in Azure in general to provision the infrastructure, and one for the Azure ML, and this is for the pipeline to be able to create experiments and do all the Azure ML specific stuff. This is just permissions stuff. Next, under pipelines, if I go to library, and there is a one variable group over here, and they are just a bunch of defined variables. For example, there is something called ACI deployment name, and this is Azure containers instance. The idea is that the machine learning model that Azure ML will create for me, it's gonna put that in Azure ACI, Azure container instance, and that's the name of the instance I want. And here it's the same thing, the name of the workspace, the name of resource group, and so on. Then in the pipelines section, I have a pipeline called create infrastructure. I will go to that pipeline. I can click edit. You see this pipeline exists over here. Sorry. I haven't written this pipeline code to create the infrastructure. It's already given for me in the MLOps Python project. I have just directly pointed to that. And over there, you can see actually there are some variable groups defined, and all the magic lies here. So it executes an ARM template that contains the cloud environment, and that's given for you from Microsoft. You can customize that cloud environment as well using some configuration files in the MLOps Python. Okay? When this pipeline gets executed, which is this one, you're gonna get all the resources over here. So if I go to Azure Cloud Burst, all those resources are provisioned and created by this pipeline. And this is really good because that means I have a repeatable deployment for my ML infrastructure. I have application insights, I have Key Vault, I have Azure Containers Registry, I have a storage account, I have machine learning, I have Azure Containers instance. Everything is just created with a single click. Okay? Now our infrastructure is ready. Any questions regarding this? Perfect. We can continue. Next, we're going to train our model. So to do that, we're going to upload or link our data set, right? So in order to train our model, we need a data. So we need to make sure that data exists in Azure ML. We need to create a model training pipeline and then execute it, and then we can look at it in Azure ML. So if I go back to Azure ML, if I go to the datasets over here, you will see that there is a dataset I added called AutoMG. In this case, I added a CSV file, but in a real production project, you don't want to add a CSV file. You want to connect to a live data source. Maybe it's some files that you are dumping to Azure storage account. Maybe it's Azure SQL Server, whatsoever, but it should be a live data source. Okay? Next, I will create the training pipeline. So if I go here, you will see that there is a pipeline called model training. If I click edit, oops. Again, this pipeline exists under MLOps Python project, right? So I don't need to write it. It's already there for me. If we look at the code of the pipeline, there are so many details happening over here we don't need to care about, but the whole idea is that it's gonna go pull out your code, execute it, create the experiment, push the pipeline code, and do all the stuff for you. You don't need to write that code. Okay? And finally, we're going to deploy the model. Okay? And that's the final pipeline we're going to execute. So again, we're going to create the model deployment pipeline. To do that, we need to update the source pipeline because the model deployment pipeline needs to know about the model training pipeline in order to deploy it. Azure MLOps by default comes up with a step to train in Azure Kubernetes service and Azure Web App. I removed that and just kept it for Azure Containers instance. So by default, it will try to deploy your model in Azure Kubernetes, Azure Web App, and Azure Containers instance. I just left it for one. Run pipeline, check in Azure ML and test the model. Okay? Let's have a look again in Azure DevOps. I will go to pipelines, and now we're going to examine this model deployment pipeline. Oops, I need to edit it. again, this pipeline already exists under MLOps Python project. And if we go there, you will see that I needed to put the source pipeline over here to the model training so that it knows where the model that it trained exists so that it can deploy it correctly. That's the only change I need to do. And here you will see that there is a step to deploy in ACI. So deploy in ACI. Oops, I need to remove this. So this one, okay? If you look at the original repo in GitHub, you will find that actually it deploys to more instances. So if I go to here, pipelines, CD, you will see that there used to be a stage to deploy in AKS. I don't need it for this demo, that's why I removed it. And it deploys also to web app, sorry. It's here, okay? After the pipeline gets executed, the model will be deployed. You can find that deployed model in the endpoint section. Remember, we said that after Azure ML finishes the training, it's going to create a model. That model will be served as an endpoint. You can see the endpoint over here, MLOps-ACI. I'm going to click here. There is an option to consume that. I'm going to click consume. Copy. I can test that actually. If I go to Osman. So I'm going to send a request. And you see, it succeeded, 200. I got the result. And actually, I want to try something interesting. I want to put blah, blah, blah. What's happening? Sorry. I need to. I'm putting in the response. So in the body, I'm going to put something blah, blah, blah. I'm just going to make it problematic request and send it. Of course, 502, bad gateway because it didn't expect that. I'm going to leave that for a few seconds while we look. I want to, just in order not to cheat for you, I want it to appear in application insights, and that's going to take a few minutes. So we can look at something else in the meantime. If I go here to experiments in Azure ML, I can see our experiment, AutoMBG MLOps Python, right? That's the name. We named it in VS Code. I can see different details about experiment and so on. This is Azure ML related stuff. I will not go. I will not dig deep over there. But what I want to show you is in the pipeline section. If I click on this one, pipeline, and I need to.
How does it generate the names there? Since they're letters.
Yeah, it's some random names from Azure. Yeah.
Can you set those when you run the experiments to be something meaningful?
These are the experiment runs. As far as I know, you can set them. So the configurations over here allows you only to change the experiment name. But each run instance, this is random name. Maybe it's configurable, frankly speaking, but I'm not quite sure if that's possible.
It would be nice if you're changing parameters to know kind of which model, which parameters you're running, what the learning rate was, and stick that in the type.
Yeah, or possibly you can use tags actually. So over here there are some tags, and the interesting part over here you can see the corresponding build URI. So if I click here, I can see the corresponding build, and that's very interesting, right? Because it means I have a link between Azure ML and my build. And we know in Azure Azure DevOps, if you have the build, then you can connect everything else, right? You can look at the code chickens and all that stuff. And that gives you an end-to-end visibility from Azure DevOps, even down from the requirement. If you are linking the requirement to your code chickens, and then the code chicken gets linked to the build gets links to Azure DevOps, to Azure ML. So you see everything end-to-end. We didn't have that in Google Collaboratory. So we can go back to Azure and actually have a look at application insights. And you can see here, we got few errors, right? That's because I sent a problematic request. And here I can see there's some server requests I have sent, and that's simply because I ran a request. And yes, we have a visibility over our model actually. So, what's the outcome of what we have done? Oops, it's still. So, the first thing is do you remember when we spoke about Google Collaboratory, we said we have those problems? Using MLOps Python project, we fixed the infrastructure problem, right? We have source control over our experiments and models. We can version our models because that exists in Azure ML. We can even retrain the models, right? Because it will be as simple as triggering your build pipeline. Do you remember the build pipeline we had for model training? We can reschedule that pipeline. We know that, okay, we want to retrain on our data every 8 hours. We can do that as long as we have the resources. And so many other benefits like model training and so on. And that's it. Do you have any other questions? Other than that, if you want to learn more, you can look at the MLOps Python project. And I have a course on Pluralsight on that topic called ML Demystifying Machine Learning Operations. It's just some marketing name from Pluralsight. I don't know why they called it demystifying. And yeah, so I think we have 4 minutes, right? Before the next session. So feel free to ask any questions.
Yeah, we've got a 15-minute coffee break.
Okay.
Yeah, we have 2 minutes.
2 minutes? Okay.
2 minutes.
Okay.
No, it's 2 minutes left of your session, and it's 17 minutes for the next session.
Okay. Any questions before the coffee break? Okay, yeah, sure.
This MLOps Python project, it seemed like it was quite a while ago since it was last updated and released. Is it because it's stable and nothing needs to be done, or do you know if it's abandoned or?
I don't think it's abandoned. There are few open issues over there, frankly speaking, but it's I would say it's quite stable actually.
All right.
Yeah. Sometimes you need to, swiggle a little bit around it, but it's quite stable. I have tested it, and at least in a couple of bugs we have in my employer.
Are you using Azure ML in your processes for real, or are you experimenting with it, or are you using it as you display here all the way to production?
One more question, like one more.
So the service you were showing us from Azure,
Yeah.
when you were doing the experiments and data and everything, are you leveraging this at your workplace?
Yeah, of course.
All the way to production?
Yeah, of course, yeah. I mean, it's used within Microsoft themselves, so
Yep.
yeah, it's quite mature.
I have a question about when you work with machine learning in the big picture, is the best programming language is Python, if I understand it. It's the best in every platform.
It's a very interesting question because, best programming language, this can goes into like, tough discussion, but I would say, Python. Some people prefer R, but based on my experience, I would say Python. At least you can leverage Python for other stuff, like creating web apps, creating a script, and so on. Like knowledge-wise, I would say Python is more valuable than R. But I know so many people are into R, and they prefer R. And actually, there is a similar project, MLOps, similar to that project, but for R. You can find it in GitHub as well. So, maybe one final question? If there are no questions, then we can jump to a coffee break. Thank you so much.